So I'm very excited about this topic because I've been working with vitamin C ever since I wrote a textbook on antioxidants in the 1980s. It was the first book to really position antioxidants as very important ingredients of dietary supplements, and also to educate people about antioxidants as frontline defense against toxins and against infection and against all sorts of bad things that can happen to the body. And I'd like to think that that helped to make antioxidants into a household word. So when Daniel suggested that we have a vitamin C product, it just made sense. And he came up with this product called Neuro-C, liposomal vitamin C, which is a more advanced technology for delivering vitamin C into the blood. So Daniel and Jim Springer, BrainMD's general manager, brought it to my attention, and we went right ahead with it. So this is a liquid, very pleasant tasting, and 1 tablespoon delivers 1,000 milligrams of vitamin C. And these days, in the age of immunity, that's really the dimension of dosing that we need to think about for vitamin C. So we presented this product for both immune defense and for brain function because although vitamin C has been thought of over the years as being good for colds, it actually has a huge range of important benefits for the body, for all of our cells, and it's especially concentrated in the brain and in the immune system and in the adrenal glands, which have to do with stress. And we're gonna be getting to all of that. So the one thing, if nothing else, that I want you to take home today to understand vitamin C is that it's a molecule that readily gives up electrons. So what do electrons have to do with life? Well, everything, because as we consume our foods, we derive high energy electrons from our foods, and we convert that electronic energy literally into chemical energy, which then drives all of our body processes. Unfortunately, we have to use oxygen to do that. And as we do these electronic conversions, we produce electronically activated oxygen atoms called oxygen free radicals, which are a threat. They're an existential threat. They're a threat to all of our cells every moment that we're alive. And one of the major protections, the first line of defense against oxygen free radicals and other types of molecules that can be toxic, is vitamin C. Now, whether they be so-called free radicals, which is a term that gets used pretty freely, although I think most people don't really know what free radicals are, or whether they're just routine toxins, vitamin C will protect against all of them. And why is that? Well, let's start with the free radical issue. So molecules that don't have paired electrons are not stable. So back in the old days, with my then colleague, Dr. Stephen Levine, another Berkeley PhD with whom I wrote the antioxidant book, we used to talk about electrons wanting to be in stable relationships. So electrons wanted to have companions. And that actually is the case in nature. Electrons need to be paired or else their molecules are going to be reactive. So if the molecule doesn't have a paired electron, it's reacting, it's attacking other molecules, trying to take away their electrons. So free radicals then are the most aggressive electron stealers. And this process of stealing electrons is called oxidation. And practically all the toxins that we know of are oxidative in one way or another. They can steal one electron at a time, they can steal two electrons, or whatever else they do. It pretty much comes down to taking electrons away from functional biomolecules. And by doing that, it damages all sorts of molecules in the cell, very often also the DNA. And so vitamin C readily donates electrons to neutralize these more or less aggressive toxins. So it'll donate single electrons to free radicals, it'll donate double electrons, and it is the very first line of defense against toxins, including these internally generated oxygen free radicals that we cannot avoid making, and which pretty much are the reasons why we don't live forever. Barring stepping in front of a bus or something. But as the decades go by, we keep making oxygen radicals, and they chip away at our health until eventually we come to the end of the line. But who knows what the end of the line would be? And so having our cells and our tissues being fully saturated with vitamin C is a big step towards having a long life. And then, in addition to being an antioxidant, by being such a generous electron donator, vitamin C also makes available electrons that are needed by various enzymes in the body. So we have a number of enzymes that need electrons to power the reactions that they make possible. And they draw on vitamin C as the source of electrons, specifically on vitamin C. So vitamin C is not only an antioxidant, as we think about it, but it's also an essential cofactor for a number of enzymes. And I'm going to be introducing you to those. Now, sorry for this ugly slide, but it has to make a point. Back in previous centuries, sailors away from land for more than a few weeks at a time began to develop symptoms that for a long time were quite mysterious. So their gums would start to bleed, their teeth would start to fall out. They develop foci of bleeding, more or less diffuse foci all over their bodies, including on their limbs, elsewhere on the body. Their hair follicles would become abnormal. Their hairs would become coiled. That would be more or less a giveaway. They would have easier bruising. They would have joint and muscle problems, poor wound healing, and mentally they would start to go to pieces. First, they would have fatigue. Then they would just have a general, malaise. Very often, depression would be part of the symptoms. Thinning of the bones. Sometimes the bones would almost turn to jelly, and we'll understand that more as we go along. And we measure that these days by the plasma vitamin C being lower than 11 micromoles per liter. That's the level at which we say a person has scurvy. And if this is not fixed, if the vitamin C is not repleted, then the person dies. So on many long distance voyages, more sailors, more than half the crew would die. And certainly in the 17th and 18th centuries, more sailors died from scurvy than died from war or from any other cause. So you might say, well, that was a long time ago. Used to be called the pirate's disease, but it's actually still around. And scurvy was the reason for what is arguably the first recorded clinical trial ever conducted. Dr. James Lind, a naval medical officer, conducted an experiment on board a British ship, an English ship, in which he had 6 groups of sailors with scurvy. He had 2 in each group. How's that for an N, Daniel? He had 2 in each group. He gave one group limes, and then he gave the other groups all kinds of other weird stuff, vinegar and mustard seed and all sorts of other stuff. And within a few days, the 2 who had got the limes were feeling so much better that they could help Dr. Lind to administer to the others and make them better. So already then, by 1747, it was becoming clear that something in lemons could improve and actually cure scurvy. Lind, for whatever reason, was quite hesitant about his findings, and it actually took another 100 years before the English Navy formally instituted having limes on board ship. So subsequently then, getting into the 20th century, vitamin C was extracted from bell peppers, really, and purified and found to be the anti-scorbutic factor. And that's how the term ascorbic acid arose for vitamin C, ascorbutic or ascorbic acid. And then between the time that vitamin C was discovered, getting into the 60s, Professor Linus Pauling, 2-time Nobel Prize winner, popularized it by writing a book called Vitamin C and the Common Cold. And it became very controversial because he was really operating mostly on gut instinct. But then a modern pioneer arose, Dr. Mark Levine at the NIH, who settled in the 1980s and proceeded to systematically work out vitamin C. So 136 minimum peer-reviewed publications on C. He's the one that really worked out the biochemistry and physiology and physiopathology, if you will, of vitamin C. And from my point of view, it was his work is very welcome because it puts on a solid foundation our understanding of vitamin C. So scurvy dates back then to the age of the time of Hippocrates, and it's still around, unfortunately. 74% in northern India, 7% in the United States. In industrialized countries, particularly low-income populations have higher risk of scurvy. About 17% in the US, around the same range in the UK, 95% of the homeless in Paris. Oh, there's a typo, made a mistake, that's terrible. At risk for scurvy, because these factors tend to burn away vitamin C and tend to not add vitamin C into the body. And the body doesn't store vitamin C, so you run out of it very fast. Smokers burn it away. In fact, the recommended dietary allowance is actually higher for smokers because they burn away so much of their C, which totally makes sense because cigarette smoke is just loaded with free radical and other oxidative toxic activity. Alcohol abusers, who pretty much run out of everything, the elderly, those under severe physical or psychological stress, people on TV dinner diets, picky eaters, including kids. Iron overload can deplete vitamin C. People on dialysis, chemotherapy, and the critically ill. So any population, any individual who is under any undue stress or who has a flawed diet is at risk of developing either an outright scurvy or a hypovitamin C state that has some of the symptoms of scurvy. So if you run into particularly an older man and you look on his forearm and you see black and blue spots, especially if they're sort of spread under the skin, ask him about his diet. You may find out that he's one of those TV diet eaters. And those bruisings and bleedings are probably scurvy. And low blood levels of C, either scurvy or subclinical vitamin C deficiency, are associated with low mood, anxiousness, impaired cognitive function, and also we know from the classical scurvy literature with changes in personality and so on. So a number of doctors have made case reports in the recent literature indicating their surprise that they have patients coming in who are exhibiting signs of scurvy. So they go through all of the diagnostic stuff and eventually they ask the question, well, what's your diet like? And they found out that one man was eating white bread and cheese for years. Another man was persisting totally on TV dinners. And those people are very definitely at risk of scurvy. Now, one of the major enzyme activities that need vitamin C are to make collagen. And collagen is a very, very important structural component of the body. If we had no collagen, we'd probably be blobs, sort of running along, sort of oozing along on the floor, because collagen gives us the tissue structure and organ structure that we need to have form. And so on the left, microscopically, are two collagen fibers. As a dimension, these two fibers would be about 10 times the diameter of a red blood cell. And they can be very long. They're stitched together, and they make the connective tissues. They're a major component of the connective tissues that give the form and structural integrity to our organs. And on the right, you'll see a simulation of how collagen fibers can be knotted together. So think about under the skin, for example, under the dermis there are sheets of collagen that actually, if they're flat, will be beautiful, youthful looking skin. And if they're becoming folded or if they're becoming interrupted due to poor nutrition or excessive exposure to sunlight, which can destroy the collagen, etc., then you can have kinking in the sheet and wrinkling. So collagen production is a major, major issue. Now, a little while back last year, one of our marketing staff said to me, Paris, collagen is such a hot issue. Can we have a collagen product? And I thought, well, let me go look at collagen in the brain. And sure enough, the brain needs collagen because it builds the walls of the blood vessels. It's important for the structural integrity of the blood vessel walls, but also I was surprised to learn that we actually need collagen to make synapses in the hippocampus and all through the brain. So the synapses are the connections between nerve cells, and they need to have a structural anchoring where the two nerve cells come together. And sure enough, a particular form of collagen, which is not formed into fibers, but which nonetheless is structural, is found and essential for making synapses. So vitamin C is highly concentrated in the brain. There are special transport proteins that pick it up from the blood, pull it across the blood-brain barrier, and concentrate it into the neurons. And it's estimated that the concentration of vitamin C in neurons is 100 to 200 times the level in the blood. It's very highly conserved. The neurons hold on to it for dear life, and it is by far the major water phase antioxidant inside the nerve cells. And this is very important because the nerve cells are making a lot of energy. And the more energy a cell makes is the more oxygen-free radicals it'll generate. And the nerve cells are loaded with fatty acids, not fats. These are not fats, but they're parts of substances called phospholipids, which make up the membranes of the nerve cells and make up the synapses and make up the mitochondria and all of the, practically all the other cellular structures that make neurons what they are. And as they're cranking out free radicals, they're actually in danger of damaging their own structure and accidentally creating suicide. So C is vital for their protection, but also enzymes draw on C in the neurons to make the transmitters, very important transmitters, dopamine and norepinephrine from tyrosine. So these are specific enzymes that need vitamin C to make these transmitters. I also learned that receptors for GABA and glutamate, possibly for other transmitters, are regulated by C. It sort of comes down to the more antioxidant protection you have inside of your brain cells, all of your brain cells, is the better your neurotransmitter functions are going to be. So the most healthy state is to have a very adequate level of antioxidants and to not allow free radical activity to get out of control. Then there are other enzymes in the brain that also need C to make tyrosine, which of course then goes into the dopamine and norepinephrine pathway, to make carnitine, which is very important for generating energy from the foods, and to make vasopressin, a pituitary hormone that helps control blood pressure. And interestingly, the highest level of vitamin C anywhere is in the pituitary. And then I mentioned earlier that collagen in the brain is important for the blood vessel walls and for synapses, but also to make the insulation of the myelin sheaths. And recent hypotheses, recent work is suggesting that certain brain abnormalities, certain long-lasting brain abnormalities may have to do with poor timing, poor coordination between neurons. So the electrical impulse is flying along the neuron, but the timing has to be just right for the impulses to meet at the synapses or to interact at the synapses. And if the myelin insulation is not good, then you can have all sorts of difficulties, clinical difficulties that develop from that. Vitamin C is also very important for immunity. So people who are under infectious stress have higher turnover of C. And this can actually draw down their tissue levels because it's not stored in the body. And this then is a vicious cycle that makes them more vulnerable to all sorts of invaders. And C helps to maintain the structural integrity of the skin, which is the first immune defense barrier. It's our first level of protection against invasion. Just think if you didn't have a skin, right? And the long airways, and probably also the the GI linings as well. And all of these are barriers to agents that may penetrate, whether these are living or non-living. And giving C enhances the healing of wounds after surgery. C also has this interesting property of promoting a clean means of suicide by immune cells. Now, what would I mean by that? Well, when you have an area of damage anywhere in the body, immune cells hurry there. So they're all security force. They get there as fast as they can, and they get into all these activities, They generate their own free radical toxins to try to kill invaders or whatever they perceive as being foreign. And a localized, very toxic zone develops. And some of the immune cells are not going to survive that. So they've basically given their lives for preserving the community of cells. And having C around means that they can finish their lives by a clean mechanism called apoptosis, which means that they die without drama, they die without making a big mess, and therefore it's easier to clean up their carcasses at the end. C is also accumulated by white cells, white immune cells, to 50 to 100 times the level in the blood, which helps to protect them against such accidental self-destruction. So if you're well supplied with C, your immune cells have a much better chance of keeping the fight localized and maybe not having to commit suicide. And then C also supports and enhances natural killer cell activity. So the natural killer cells are the heavy hitters. They're the ones that come in to do the ultimate job against cells that are abnormal. And that they also work better when there's C around. So looking at it then graphically, neutrophils and other white cells arrive in a blood vessel, and they push through the wall of the blood vessel, and they go through what's called chemotaxis, where they follow a chemical scent to the site of the problem, and vitamin C enhances their ability to follow that scent and to actually be mobile and get to the area of activity. And then they have a process called phagocytosis, which is a fancy scientific name for eating the invading particle or agent. And they take them in, they eat them, take them in, and then they secrete some very powerful free radical molecules that are meant to destroy the agent that they've taken in. And sometimes they'll liberate the free radicals at a short distance. The whole idea is to destroy the offending particles. And so vitamin C is required for all of these immune functions and more. So then we come to the adrenal glands. These are glands that are on the top of each kidney, and they have an outer cortex and an inner medulla, and they're very, very important for handling stress. So they coordinate with the hypothalamus and the pituitary in the brain to put out hormones that help us to manage not only emotional stress, but also chemical and infectious and even physical stressors. And the adrenals require vitamin C to very high levels. Both the cortex and the medulla get levels that are almost as high as the brain. And the medulla makes mainly epinephrine, an anti-stress hormone, and one of the enzymes that makes epinephrine requires vitamin C. The cortex makes steroid hormones that deal not only with stress, but also with mineral balance in the body. And we don't know of a specific enzyme that the cortex needs, but it seems to need a very high level of antioxidant power in that zone. And so by enabling healthy functioning of the adrenals and of the pituitary, which has the highest level of vitamin C is crucial for coping with stress. And we find indeed that even emotional stress tends to lower the blood levels of C. And vitamin C also has a role in regulation of genes. Our DNA is typically wrapped in proteins. When you watch the crime series on TV and stuff, they don't really explain that the DNA is not usually exposed. The DNA only becomes exposed when it's going to be read out as genetic code. But typically, it's held in a inactive fashion by being wrapped in proteins. And this is called epigenetic control. These are very special proteins, and they have, very special roles to play. But the activities of these proteins are controlled. There's another typo. Mostly by adding or removing methyl groups. And things like S-adenosylmethionine, which BrainMD provides, we provide the highest quality SAMe in the world. SAMe is necessary for enzymes that add and remove methyl groups from the proteins that control DNA. And certain of these enzymes are found to require vitamin C. Also, in the cells that produce the myelin insulation for neurons, vitamin C is necessary for similar epigenetic changes that control the activation and maturation of these cells and their capacity to make myelin. And vitamin C also appears to be essential for the epigenetic regulation of maturation of T cells, which are very important for long-term immune responses, such as maintaining a memory for offending agents that they have seen before. So the T cells, for example, are very, very, very important for a healthy vaccination status. Now, the Neuro-C product is unique in being a liposomal product. And liposomes have been known for well over a half century. So they're creations, they don't occur naturally, but they have this really nifty structure where they're more or less spheroid, and they have a cavity in the middle. So around the edge are two layers usually of what's called phospholipids, which are the very same substances that make up our cell membranes. Now, some of you have heard me talk about cell membranes, which are the layers that go around the outside of our cells, all our cells, and which also make functioning structures inside the cell. So the liposome structure is very similar to the cell membrane structure. And the reason for using a liposome to deliver vitamin C is that you load vitamin C into the cavity, that central cavity, and then you make it into a dietary supplement. You give the liposomes by mouth, and they get into the intestine, and they get close to the cell membrane, maybe even directly interact with the cell membrane, and more efficiently deliver vitamin C into the cells or into the blood. And so we don't really know how liposomes deliver vitamin C. There's like 7 different ways in this diagram, but let's just say that one way or another, they raise the levels of vitamin C. At least our liposome preparation was studied in a human study and found to deliver more vitamin C into the blood than regular vitamin C. So at the bottom line is those solid black circles is a placebo. You see that the vitamin C level doesn't go up at all over 4 hours. The open circles are a regular vitamin C. And then the triangles, the dark triangles, are the liposomal vitamin C. And you see that the levels in the plasma, the blood plasma, go higher over 4 hours than they do with regular vitamin C. So who can benefit from Neuro-C? Well, I don't even need this slide. I could just say everyone. Anyone who wants a fully functioning brain, because vitamin C is crucial. Adequate and fully supplied vitamin C is crucial for the brain to be protected against damage from oxygen free radicals and other free radicals and toxins from the outside, and for the brain to have adequate and balanced neurotransmitter status, and for a number of for the blood vessels of the brain to have full structural integrity and not maybe have microbleeds such as we see in certain conditions. And so anyone wanting to have a fully functioning brain needs vitamin C. Anyone wanting a fully functioning immune system. Anyone currently facing stressful circumstances. Now, who would that be? Can we guess? Would it be me? Would it be you? Would it be Daniel? Who would it be? Would it be a person in India right now? Or a person in Jamaica where the tourism industry has been ravaged and people have lost their jobs and we have coronavirus spreading down there? Anyone concerned about environmental toxins? Anyone with ongoing inflammatory imbalances? So supplemental C has a direct effect on lowering C-reactive protein, which is an indicator of an imbalance of the healthy inflammatory response. So vitamin C by itself can bring C-reactive protein down into normal range. And generally, C taken by mouth, particularly at the doses that we're recommending with Neuro-C, can put a blanket on free radical and other types of inflammatory type imbalances. Anyone who is a current or former smoker, drinker, drug abuser can benefit from C. Anyone wanting a long life, optimal health, and really happy level of well-being. So how to use it? For basic maintenance, 1 tablespoon, 1,000 milligrams. Children ages 4 and up can take the same dose. For additional maintenance, including for the immune system, 2 tablespoons. So 2,000 milligrams a day has been found consistently in clinical trials to reactivate immune cells. So immune cells that are in the fight, if they run out of vitamin C, will come to a halt. They can no longer move. They can no longer carry out their killing functions. And if you can give 2,000 milligrams a day, you can get them moving again and get them to a level again where they're effective security forces for the body. If under stress of any kind, severe stress, relatively severe stress, you can do the bowel tolerance trick. You take a tablespoon every 2 hours or so until your bowels begin to get loose. It's not necessarily uncomfortable. Once you begin to feel a little bit of loosening or hear a little bit of growling, then stop, and then after a few hours, go back onto that regimen. And I can practically guarantee that after a day of that, you're going to be functioning and feeling a lot better. I've done it so many times. It's compatible with all of the other supplements from BrainMD, suitable for vegans, free from dairy, glutens, corn, nuts, eggs, yeast, artificial coloring or flavoring. Now, last week I did a session with Daniel on immunity. And so I felt it would be good to sort of quickly summarize what BrainMD could recommend for improving immunity. So the first really is NeuroVite Plus. It supplies all the vitamins and minerals essential for immunity, except for iron, which for reasons of safety, we can't mix in with the other ingredients, but we do have an iron product. And if a person is tested and found to be needing iron, our iron product is a very gentle way to replete it. Then the Neuro-C. And for immunity, I definitely would like to recommend that people take at least 2 tablespoons a day. The omega-3 power, 2 soft gels a day. Ideally, they should monitor their omega-3 index and target 8 to 12%. And we're coming up very soon with a fully liquid omega-3 power called the Squeeze, which is an excellent product for people who don't like capsules. Then vitamin D3 is very important for immunity. And so 5,000 IU a day, follow the blood levels and target this range of 30 to 100 nanograms per mil. And if C-reactive protein and or IL-6 are high, we recommend adding in not just the Neuro-C, but also the brain curcumins. So the curcumins are able to bring down very high levels of C-reactive protein. And as I mentioned earlier, if your iron is low, take the BrainMD iron. But very important to have your iron measured. It's not appropriate to just take iron as an everyday supplement because iron can actually exacerbate free radical activity in our cells and in our body overall.